The difference between tests that exist and tests that actually protect your codebase is a simple one. Tests that run automatically on every code change protect you. Tests that only run when someone remembers to run them do not. Think about what happens in a typical week without CI. Monday, a developer pushes a change. Tuesday, someone else pushes a change on top of it. Wednesday, 2 more changes go in. Friday afternoon, someone runs the tests for the first time all week and finds that something broke on Monday. Now nobody is sure which of the 4 changes caused the failure. The context for the Monday change is 4 days old. And everyone is trying to debug a regression at 4:30 on a Friday. GitHub Actions solves this. It is the most accessible continuous integration platform available. It is free for public repositories, it requires no external infrastructure to set up, it runs on GitHub's own managed servers, and it integrates directly into the pull request flow. In this episode, we are building a complete, production-quality CI workflow for a PyTest test suite using GitHub Actions, from the first line of YAML to a green status badge in the README. By the end, every push to your repository will automatically run the full test suite, report the results, and if you configure branch protection, prevent a merge if anything fails. GitHub Actions workflows are defined as YAML files inside a .github/workflows folder at the root of your repository. If the .github folder does not exist, create it. If workflows does not exist inside it, create that too. Then create a file inside workflows called test.yml. This is the file that tells GitHub Actions what to do and when to do it. The first thing to define is the trigger, the on section in YAML, which specifies the events that cause the workflow to run. The standard setup for a test suite is to trigger on 2 events. First, push, filtered to the main branch. This runs the tests every time code is pushed directly to main. Second, pull_request, also filtered to the main branch. This runs the tests on every pull request that targets main, before the code is merged. The pull request trigger is the more important of the 2. It gives you test results before the code is in the main branch, while it is still easy to reject or revise. After the merge, a failure means you have broken main and everyone on the team is affected. Before the merge, a failure is a private signal that the author needs to fix something. That ordering a test first, merge after, is the core value proposition of continuous integration. The next section of the YAML defines the job. Give it a descriptive name like run tests. Set runs on to Ubuntu latest, which tells GitHub Actions to use its managed Ubuntu Linux runner. GitHub provides this runner for free and it is the standard environment for Python projects in CI. Inside the job, define the steps array. Each step in the array is one discrete action. Step 1, use the actions/checkout action to clone your repository onto the runner. This is a standard action maintained by GitHub and it is the first step in almost every workflow. Step 2, use the actions/setup Python action and specify your Python version in the with block. Pin a specific version like 3.12 rather than using latest, so your CI environment does not silently change when GitHub updates the default. Step 3, run pip install -r requirements.txt to install your test dependencies. Step 4, run PyTest with your preferred flags. This is the complete minimal workflow. 4 steps, each doing one well-defined thing. GitHub Actions runs them sequentially and stops the workflow if any step exits with a non-zero status code, which is how it knows that a test failed or a command produced an error. The workflow result, pass or fail, is reported back to the pull request as a status check. Let us add 3 improvements that take this workflow from functional to genuinely useful. First, add test coverage reporting. Add PyTest COV to your requirements file, and update your PyTest run step to include the coverage flags, --COV equals your source directory and --COV report equals XML. This generates a coverage XML file after every run. Then add a step that uses the CodeCov action to upload the report to CodeCov, which is free for open source projects and gives you a visual coverage dashboard and a coverage badge. Second, add artifact upload. Use the actions/upload artifact action to save the coverage report and the PyTest HTML report as downloadable artifacts attached to each workflow run. This means if a run fails, you can download the detailed test report directly from the Actions tab without needing to reproduce the failure locally. Third, add a status badge to your README. Copy the badge markdown from the Actions tab in your GitHub repository and paste it at the top of your README. A green passing badge visible at the top of the README tells any visitor that this project is actively maintained, that the tests are real, and that they pass. Coverage reporting is one of the fastest ways to make your testing practice more visible and more credible. When a coverage report is attached to every CI run, anyone on the team can see which files have no coverage and where the biggest gaps are. This changes the conversation around testing quality from subjective to data-driven. Instead of saying "I think we have good coverage," you can say "we have 84% line coverage with the 3 lowest covered modules identified for the next sprint." Environment secrets are the mechanism GitHub Actions provides for passing sensitive values into your workflow without exposing them in your YAML file or in the run logs. To add a secret, go to your repository settings, select Secrets and Variables in the sidebar, then select Actions, and then click New Repository Secret. Give it a name in all caps with underscores, like API_key or base_URL, and paste in the value. In your workflow YAML file, reference the secret using the secrets context, $open brace secrets. Your secret name close brace. Pass it to your test run as an environment variable using the env block inside the step definition. Inside your PyTest code, read it with os.environ.get. GitHub encrypts secrets at rest and automatically masks them in workflow logs. If your code accidentally tries to print a secret value, GitHub replaces it with asterisks in the log output. Secrets with repository scope are visible to GitHub Actions runners but not to external contributors who fork the repository, which means pull requests from forks do not have access to your secrets. This is the correct, standard way to handle credentials in CI. One important note about pull requests from forked repositories: when an external contributor forks your repository and opens a pull request, the workflow runs in their fork's context, not yours. Secrets are not passed to workflow runs triggered by pull requests from forks. The standard solution is to design your tests so they can run without secrets in a limited mode, using public test data or mock responses when real credentials are unavailable. This pattern also makes your tests more resilient overall, because tests that run without external credentials are faster, cheaper, and more reliable in CI. The final piece that turns CI from a reporting tool into an enforcement mechanism is branch protection. Go to your repository settings, select branches, and add a branch protection rule for main. Enable the option that says require status checks to pass before merging. Search for your workflow name in the required status checks list and add it. Now, no pull request can be merged into main unless the GitHub Actions workflow passes. A failed test means the merge button is grayed out and disabled. This is what makes CI a team guarantee rather than an individual best practice. Without branch protection, CI is optional. Anyone can merge failing code by just ignoring the failed check. With branch protection, CI is enforced at the infrastructure level. You cannot merge broken code. That is the standard in every professional software engineering team. A complete GitHub Actions setup for your portfolio project should include a workflow file that triggers on push and pull request, runs the full test suite, and generates coverage, a status badge in the README, and a branch protection rule on main. Those 3 things together demonstrate that you understand not just how to write tests, but how to build a quality enforcement system around them. In the next episode, we are writing the QA resume that gets you into the teams that use these systems. I will see you there.